Okay, hey guys, this is going to be a crash course on section 7.2. We've already talked about it in class a couple of times, but I'm just going to give you a few more examples. I'm going to try to fit this into one video so that it's, available to you guys as soon as possible. What we have is the following definitions for these fraction powers. A 1/2 power works as the square root of a, and I'll give you a demonstration. Do you know that if you take the square root of like 7 and you multiply it with another square root of 7, that what you would get is the square root of 7 times 7 is 49, and lo and behold, what you get is 7 again? Well, the idea is instead of writing the radical, the invention was that could be seen as the 1/2 power times another 1/2 power. And when you times those together with the power rules, you add the powers, and once again, you get 7. So the idea of the square root being the 1/2 power holds water, as they say, okay? This one also, let's say 2 to the 1/3 power, and let's write it differently this time, cubed. Well, the power rules would say that's equal to 2 to the 1/3 times 3, which is equal to 2 to the 1, which is 2. But if you write this as a radical, it becomes the third root of 2 cubed. You see how that's fitting? You see how these guys are all in agreement with each other? So we're trying to convince you that, the 1/3 power is the third root, the 1/4 power is the fourth root. It makes sense with numbers, and it's an invention that, man, that's how we talk about root powers, is by using fraction powers in math classes beyond this one, okay? So we have some homework here, and it says basically, then it kind of evolves, like that one I just did, the cube root of 2 and then cubed is really 2 to the 1/3 power being cubed, which is 2 to the 1/3 times 3, like I showed you. So we have 2 to the 3 over 3, if you will. Okay, 2 to the 1, and finally 2. But if we take the cube root of 2 and hit it with just, I don't know, what if we hit it with a 2? Well, that means what we've got is the cube root of, let's go to the powers. It's 2 to the 1/3 power, but then only squared. So, but we still do the same thing, 2 to the 1/3 times 2, and you end up with 2 to the 2/3 power, and these two are known to be equivalent to each other. I have a crazy example up here, 8 to the, that's a typo. Should be 5/3 right there. I just noticed that. So it says 8 to the 5/3 power can be written as, well, the way I'm writing it is the third root of 8 to the 5. Okay, now wait a minute. The third root of 8 is actually known. It's 2 to the 5, and you end up with 32. And that's this example here. But the other way you can write it is you can simply go, well, that's equal to, from here, it's the third root of 8, and it's multiplied 5 times. Okay? So I'm just showing you the gymnastics of it all. And this can also be written as the cube root of 8 to the 5th. Notice 5, 2, 3, 4, 5 8s multiplied together. And upstairs, I used a calculator to find that's really the cube root of 32,768. And then if you cube root that with your calculator, guess what? You get 32. Okay, so that's another item here that's kind of interesting to us, but in this textbook, he doesn't really push it that much. Other textbooks I've used, you know what, I think I kind of skipped that section in your homework, but it is good to kind of see that anytime you see a problem, you can, for example, you can take, let's mess around with 4, I don't know, to the negative 5/3 power. Interesting. What do I do? And I took this off the homework, but you could still work on this. You go, you know what that is? First and foremost, it's got a negative power. Okay, so that means we're going to reciprocate the thing and write it as 1 over 4 to the... If you thought that that's what happened, it doesn't make the number negative. It means reciprocal it. Turn it over. Then you can play the game of, hey, it's the cube root. Uh-oh, made a bad example. Let's make it 5/2 power, because I don't know the third root of 4. It's irrational, but the second root of 4 I do know. That's 2. And when we take it to the 5th power, we get 1 over 2 to the 5th, and 1 over 32 is another example of fraction powers with numbers. Okay, so we're, it's kind of quick, but that's what's happening here. On the next page, I have, basically writing roots in radical form and exponential form. So you have a lot of homework at the front end that's pretty easy. You just go like, well, what if they gave us 5 and they said, oh, that's to the 2/5 power? What you're supposed to do, this is an exponential form right there. And what that means is exponent, like power, or you can call it power form if you want. And then you're going to write it as in radical form. And remember what a radical is. It's that crazy little house that square roots live under. But in this case, it's going to be, I'll write it as the 5th root of 5 and squared. Or you can write it as the 5th root of 5 squared underneath. Those are both valid forms for that. If they ask you to go to the other way, if they ask you to go something like, I've got the, the 12th root of c to the 7th power, you quickly go, well, that's c to the 7 over 12 power. You see, the thing about this is downstairs, you've got the root. That's how you kind of remember it. And upstairs, you've got the power. Yeah, I've got the power. That's what's happening with these guys, okay? But that's just the definition. And it helps us with weirdnesses like, what if they gave you like a couple more examples? I think what's next here, let's see, I haven't really practiced. Yeah, okay, we have some strangeness happening downstairs. So let's turn to the next page. Well, yeah, let's turn to the next page. So here it says, write radical expressions, simplify them using exponential form. Okay? So you take this guy, you write the base, you write the power, which is 20, over the root, which is 5. Look at the power reduce. That's the 4th root of y. I'm sorry, the 4th power of y. In the next section, we're going to actually simplify this kind of thing, y to the 20th. In fact, you already saw it, and I'll just do it for you. It's the 5th root of, and I'm going to take 20 and go, you know what? There's 4 5s in there. Look what I'm doing. This is crazy. Okay? But you can write it as 5th root of y to the 5th. You know what? There's 5 of them. I'll write them out because you know what? I've got nothing better to do. I'm just kidding. 5th root of y to the 5th. And 1, 2, 3. Oh my gosh, 2 more. 5th root of y to the 5th. And I do this actually for you guys, because this is a second algebra kind of problem. 1, 2, 3, 4, 5. Each one of these guys, you know what? That's y. And so is that. And so is that. And that. And that. And of course, that ends up being y to the 5th. Now that's laborious. The power rules helped you do that one better. Okay? This one. It says it's the square root of the 3rd root of a. Okay? So the outer power is the 1/2 power. And the inner power is the 1/3 power. And a to the 1/3 power is cube root of a. And the thing to the 1/2 power is the square root of whatever that is. And look what the power rules say. It says it's equal to, well, what do you do with powers when they go power to a power? You multiply them. It's 1/3 times 1/2. Answer is a to the 1/6 power. And if you want, you can say that's the 6th root of a. Did you know that that was the 6th root? So this is the kind of stuff you learn with roots and radicals. You learn about numbers, and it's really informative to see it happen with these fraction powers. And I guess I have one more. What I would do with this one is I would go, it's the cube root of 8 times the cube root of x6 times the cube root of y18, okay? The cube root of 8, I think you guys know, is 2. But the others, I want to show you something here, okay? When I did all this craziness, I said green. When when I did all this craziness right here, and I go, oh, there was only 4. I kind of messed that up, didn't I? So I don't have that guy. I'm glad to fix it. Glad to fix it. But I got 1, 2, 3. So actually the answer here, I didn't even jive, did it? So I'm going to fix it right here in the video. And that's what you do in math a lot of times. It's not always wonderful. Glad you know this. So y to the 4th, y to the 4th. I didn't even notice that. But I wanted to show you this. 20, when divided by 5, gives you 4. That was the answer. So why don't we do that here? X to the 6 divided by 3. And then y to the 18 divided by 3. Nice that they divide, don't they? When they don't, well, that's next section. We get 2 x squared y sixth, right? And that's that one. Okay, so it's an extremely useful thing to have these fraction powers to help us out. This is going kind of quick, showing you kind of this is the last example, I think, yeah. And so in conclusion, what you can do is you can run the regular power rules on this thing, and that's also in the homework. And so what happens is, let me write it bigger, you got 14 over 35. Now if I stop right there, you guys are going to go, hold up, I'm going to divide by 7, divide by 7. You're right. That is totally acceptable. But the other guys, look at this. I've got x to the negative 3/4, and downstairs is x to the negative. Do you remember this from section 1.5? Let me write it again. 2x to the negative 3 over 4. And downstairs is 5x to the negative 3. What we did that time was we canceled and subtracted stuff. I'm going to do that right now. I'm going to use red to be in charge here. I'm going to cancel and subtract a negative 3. And what happens to that guy? You know, turns positive on you. But it works with fraction powers too. So we have 2/5 maybe, x to the negative 3/4 plus 3. So that's equal to 2/5. And when we do that, we've got, what is that, 12? It's 9/4, isn't it? And folks, that's it. Power rules are here to stay. You go farther in math, you'll see more and more. I hope this has been a little bit helpful when you're tackling these guys. Some more examples for you. Okay, see you at the next video.